Welcome back. In this lesson we'll learn some additional facts about the way that the memory of a computer works. You will need to refer back to things we've learned already about the structure of the processor. In this lesson I'll briefly contrast the difference between memory and storage and between RAM and ROM. We'll look at how different types of memory have different speed of access and what virtual memory is. Both memory and storage can hold instructions and data, but memory holds this information using electricity and storage holds the data using some other method that doesn't require constant electrical supply. The computer's memory can be called the memory unit or the immediate access store or RAM, and the small amount of additional memory called ROM. We'll look more about that in a minute. Inside the RAM, the instructions and data that the computer uses are stored as electronic signals. RAM has random access. What that means, it doesn't mean you just go to different places at random. It means you can pick any part of the memory and you can go straight to it in one step. And it allows read-write access. That is, we can put new data into the RAM and we can take data out of the RAM. So think of the fetch execute cycle. Inside the RAM, all content is held electronically using the small circuits that are called latches that hold a charge. However, if the electricity supply to the computer is turned off, all those latches will lose power and all the data will completely disappear. For this reason, we cannot hold the startup instructions for a computer inside the RAM. That's because when you switch the computer on, the RAM is completely empty, and so the computer would not know how to start up. So this is where ROM comes in. ROM, read-only memory. ROM is hardwired in the factory with the startup instructions for the computer. It won't store new data, but it will hold the data even when the electricity is off. So ROM is used for data which isn't going to change, and the most common use of ROM in a modern computer is the startup instructions, which are the same every time the computer boots up, but need to be kept without the use of electricity. ROM is used for a couple of other purposes. If a device will never be reprogrammed, it's always going to do exactly the same thing. For example, a heart monitor in a hospital. You could store those instructions in ROM and then they can never be overwritten or changed, which could be really useful. And sometimes ROM is used to store data in a format that can't be overwritten, such as music. So you buy music, but you can't record new music onto it. There are erasable forms of ROM, but on the whole, ROM is used read-only. The clue is in the name. There are different forms of computer memory, and the closer to the processor the data is stored, the quicker it can be fetched into the processor. For this reason, modern computers have cache memory. That's a small amount of memory very close to the processor. And we've talked about this before. If a computer has got a large cache memory, then it goes more quickly. From the processor, there are various types of memory which the computer can access. Registers store one number. We'll learn more about registers in a week or two. Cache is close to the processor but not very large. RAM is much larger but rather further from the processor. And of course, permanent storage could be terabytes of data. So the lower down this list we go, the greater the storage capacity. But the higher up the list we go, the faster it is for the processor to fetch data from that area. So once again, as with so many things in computer science, there's a kind of trade-off between speed and capacity of memory. If a computer runs out of RAM, then it has to use storage, for instance the hard disk of the computer, to store some of its current data, and that will make your computer really slow down. So the processor has got registers in it, and these store single items of data. RAM stores the current instructions and data that are in use, and the processor must fetch those instructions and data during the fetch execute cycle. Cache is a kind of memory that's closer to the processor and therefore has faster access, whereas virtual memory is the use of permanent storage to supplement RAM if you run out of space. That's all I want to say for now about memory. So you should be aware of the difference between memory and storage. You should be aware of the difference between RAM and ROM and their different uses. You should be aware of the different speed of access of different types of memory, and you should be able to say what virtual memory means. So for my students, go back to that hardware workbook that I've been talking about and complete the memory section to show what you've learned and to keep a record for your revision. And in the following final 2 lessons, we'll look at storage.